In this video, we're going to take a look at baking textures. Now, as I indicated in a previous video, the bake textures is available for each material or texture set that you have. And so when you bake these textures, they're going to be applied to your additional maps for the given selected texture set. So here, let's just go ahead and select this Bake Textures option, and let's take a look at what we have in the baking dialog. So as I said, we have these additional maps, and these are the map types that you can bake here in Painter. And these maps are specific for working with the mask generators. Now, the mask generators in Painter, which we'll cover in a later video, they are utilized to create different wearing effects. And when you bake and these maps get applied here to this additional maps rollout, whenever you choose a generator to create a wearing effect, it takes whatever maps it needs and automatically uses those in the process. And so baking is going to be one of the very first things you do once you kind of get your mesh imported and your project set up. Each one of these bakers here, they're all enabled by default. Some of them have their own settings. So for instance, if you go to Ambient Occlusion, we have specific bake parameters here for the occlusion. Now, we also have these common parameters. These are going to be utilized by all of the bakers and mainly contain information about how the ray is going to be shot into the scene for the baking operation. So some of the things that we would set first would be like our output size. So we would maybe set this to, like, say 2K by 2K. We also have the ability to work with this dilation width. It's just going to push that texture outside of the UV border. And we have this apply diffusion. Now, this is going to be another process that takes place. It's a post process over top of the padding setting here. That's what this is. And it's going to take the texture and just basically bleed it all the way to texture border itself. And that is very good. So if the texture is actually mip-mapped and the resolution is decreased because of that process, you will not get any seam. So we highly recommend that you use apply diffusion, that you keep that enabled. So here for our actual bake options or our parameters, we have the first thing that we need to do is add our high definition mesh. So here I'll click this button and I'm going to go and grab my sci-fi container high, and I'm just going to add this guy in. So here I chose FBX. You can use OBJ. We support several model formats. Now in this section here is where we're actually going to control how the ray is cast into the scene. So we can choose to use either a cage mesh, or we can choose to utilize this max frontal and rear distance. And so the cage file itself, so if I enable it, I can then go and browse here for the actual cage file. What that's going to do, it's going to use that cage file as the origin from where the rays are projected. In my case, I don't use that. I don't like to use the cage files. I'm going to just use the frontal and rear distance. And what this does is it sets up like a virtual envelope around the meshes. The frontal distance serves as the origin point that the ray is cast into the scene, and the rear distance just basically tells it when to stop. We also have this relative to bounding box. This is basically going to take the information we have here, or the settings that we're using in our frontal and rear distance, and it's going to basically normalize these to a 0 to 1 range. It's like utilizing these guys as a percentage. If this is unchecked, what you're doing then is these frontal and rear distance settings, these are going to be related then to the actual object mesh size itself. So in that case, the frontal and rear distance, it's no longer normalized to that 0 to 1 range, and then the distances rely on the actual scale of the object. So in your 3D program, you'd have to, kind of measure the distances and that kind of thing to know, or to get an idea of what values you're going to put here. Here we have average normals. And this, well, it just averages the normals. I'll talk about this more here in just a bit, the average normals and ignore backface. We also have this match setting here. It's set to always, and then we have an option by mesh name. Again, I'll talk about this a bit more here in just a moment, but what this allows us to do is set up a system to where we can bake and not have to worry about neighboring geometry. So one of the things that you may typically do during a baking process is explode your mesh so that the neighboring geometry, that when the ray hits this, it's not going to get any kind of projection issues. But we can actually work around this in an intelligent way here by using this setting, and we'll cover that in depth here in just a bit. Anti-aliasing is just a way to improve the quality. So what I would recommend is to keep this at, well, 4x4 is high quality, and then you got 2x2. 8x8 is probably overkill, so I typically will just leave this at 4x4. And then this high poly mesh suffix, the underscore and underscore high and underscore low, this correlates to this match by mesh name here. And we'll talk about that in just a moment. So what I would like to do now is kind of dive just a little bit deeper into how this system works. And I'm actually going to open up a chart that's going to help explain what these settings are actually doing. So here in this chart we have this white box, and this is going to represent our low resolution mesh. And then here we have this green shape, and this is more curved, and you can see this is going to represent our high resolution mesh. And so when you're not using a cage mesh, you're going to use the frontal and rear distance setting to create this kind of virtual envelope. And that virtual envelope can be represented by this dashed square that you see here. And with this virtual envelope, the rays are shot from here. So these purple arrows here indicate the rays that are shot out into the scene and computed for the baking process. And notice that the rays originate from this virtual envelope, and they move in a direction opposite of the mesh normals. Now we need to know where to create this virtual envelope, and we're going to do this with the frontal distance. So this distance setting is going to tell us how far away from the low resolution mesh we need to start to create this virtual envelope. Now in this case I have 0.5. Now, the direction that we move is going to be either based on the mesh normals or the averaged normal. So in our case, we're going to have averaged normals enabled, so we're going to use this direction here. With average normals enabled, that means this envelope that we create is going to be continuous. So here again, I have 0.5. This is the distance setting that I'm moving. It's set as a percentage distance from the low resolution mesh because I have relative to bounding box enabled. So we know that we're moving this distance and in the direction based on the average normals because average normal is enabled. So here's my virtual envelope. Now we have an origin point where the ray can be cast. Now the total distance this ray traveled is based on the frontal distance and the rear distance. So again, the rear distance just says when the ray is going to stop. And together, the frontal and rear dictate the entire distance that this ray travels. So in this case, we had average normals enabled, so we get this continuous virtual envelope. However, if we had average normals off, we can get into a situation where the virtual envelope is no longer continuous. So with average normals off, we're utilizing the mesh normals to compute the direction. And so what happens is we end up getting kind of this blank area in the virtual envelope. So if you take a look, what happens now is the rays are cast from the virtual envelope. So remember, that's the origin point. They are now cast parallel to the mesh normals. And by doing this, you can see that there are no rays cast in this area, and this gives us like kind of a gap in the bake, and we're going to be missing some details. Now, I had mentioned that the total distance that this ray is going to travel is based on the frontal and rear distance. However, if these values are too large, you could get into a situation where this ray is going to intersect neighboring geometry. And when it does that, you're going to get these projection issues where pieces of geometry are going to be projected on top of each other. And what is typically done is to explode your mesh, meaning that you would move these pieces of geometry far enough away where that ray intersection could never happen. However, with Painter, we have the ability to utilize this match by name option. And what that'll do is it'll resolve these projection issues by comparing the rays with geometry of the same name. And only the geometries that match this naming convention will be computed in the raycast. So here we are back in Painter, and now we're going to start to bake our maps. Now the first thing I want to demonstrate is what we've been discussing, this match by name. So to demonstrate this, let's only bake the normal map. So for additional maps, I'm going to hit none, and then I'm just going to enable my normal map. I'm going to leave the settings that I have here. Notice that for mesh I have always, which means that we're not going to take any mesh parts into consideration for the baking. And so now with this setup, I'm just going to hit bake textures. And so now we have our normal map. So it appears to look okay. However, we have some artifacts here in this area. So let's just kind of zoom in and take a look. So here you can see that because this mesh part is very close to this, and the distance of the ray is far enough that it's intersecting both of these pieces of geometry, which in turn is producing this artifact we have here in our normal map. So if we go back to Baked Textures, I can fix this by changing this to Match by Mesh Name. Again, this means that only geometry with the matching naming scheme is going to be computed in the raycast. So now let's bake our textures again, and you can see now that artifact is gone. So let's jump back to our bake settings, and again we're using by mesh name for the matching, and it's utilizing this high poly suffix of _high and the low poly suffix of _low. So let me jump over to Maya and show you how this is coming into play. So here we are in Maya, and we're looking at the low resolution mesh. So let's look at this mesh item here, and you can see that the name of this is bottom_low. So notice here we have that suffix _low. Let's look at this part here. Here you can see this is bottom connectors handles _low. So again, we're using that _low suffix. And here you can see that these are two separated mesh parts. So let me just hide the low resolution and let me just show the high resolution. Let's take a look at this. So here we have the bottom again, so it's a part, and notice that its suffix is bottom_high. So the bottom_low and the bottom_high, the name bottom and bottom both match. However, the change is the suffix _low and _high. Same thing for this part here, which again, the name is actually bottom connectors handles with the suffix _high, and that name matches the low version. So if we take a look at how this works, let's just take this piece here and we'll just hide everything else. And then we'll come here to our low resolution parts here. Let's just take this guy here and we'll just hide these. And so here we have our two parts, and we can see how they're overlapping. So because these two names match, the ray is only computing for these two mesh parts. So now that we've covered these common parameters, you may be asking yourself, okay, well, how do I know what value to put for this max frontal and max rear distance? And the answer to that is it kind of comes down to just trial and error. It really helps to understand what these settings are doing, and that's why we had that diagram earlier to kind of illustrate how that virtual envelope is encompassing our low and high resolution mesh. We know that we're shooting a ray from the origin of that envelope, and we know that the combination of this frontal and rear distance describes the total distance the ray will travel. We need that ray to travel far enough so that it will intersect both the high and low resolution. And it becomes kind of a balancing act. If the ray is too long, it's going to intersect geometry, or if it's too short, we're going to lose some detail. So let me just set up an example. We'll do something pretty extreme. So let's just come in here, let's click this icon here, and let's just enter a value. So I'm going to say 0.0001, and we'll hit enter. And let's do the same thing here. So we'll say 0.0001, and we'll hit enter. We set up this distance this ray is going to travel to be extremely small. And let's go ahead and just bake this now. Okay, so now here in my viewport, we're starting to miss some details. So if we take a look over here, you can see some of the shading artifacts that we're getting. And especially in here, you can see where this just becomes very, very flat all of a sudden. And then right here, very, very flat. You can see it here on the edges as well. Let me just kind of start to move my light around here so we can see this. So very flat right here in this area too. Just kind of very flat here. We're just missing details, what it looks like. And that will give you an indication that the ray is too short. So in that case, what you would do is you'd say, okay, well, I just need to extend the ray, just make it a little bit longer. So in this case, let's just say this was the setting I had to start with. So let's say, okay, well, let's just switch this. Let's take one of the zeros out. And let's come in here and just take one of the zeros out. So let's try this setting here. And so we'll bake again. And now you can see that the difference this makes. Now I'm still seeing a little bit of an issue here in the shading. So some of the detail is starting to still missing. The ray's not long enough. So let's do this again. We'll do 0.01. And we'll come back here and say 0.01. And now we'll bake. And that cleans things up. And now we know that we're getting a nice distance setting and everything looks pretty good. On the flip side of that, let's go to bake textures and let's set something like, let's say something like 0.5. So let's say, so you may be thinking, okay, well, let's just make it very, very large. So we'll go ahead and say 0.5. We also have match by mesh name still enabled. So let's hit bake on this. And so now you can see some of the errors I'm getting here in this mesh itself. So this ray now is too far, and even though it's not intersecting with the other meshes, it's still projecting back on itself because the ray is too long. It's shooting all the way across and hitting this other edge here. So we're getting this kind of issue. So with this, you can see that it just becomes this balancing act of knowing how far apart your meshes are. The further apart your meshes are, the farther the ray needs to be, but you don't want it too high of a value, and you definitely don't want too low of a value. Okay, so now let's just run through some of these other bakers here. So we have our world space normal. We'll just enable this guy, and you can see that this has no parameters. We'll skip the ID for now. Let's come over to our ambient occlusion. We'll enable this baker. And so the ambient occlusion, it has like a quality control, basically the secondary rays. So here at 64, if you get a lot of noise in that bake, you can increase this ray count. How far the occlusion is computed is controlled by this min and max occluder distance. You have your relative to bounding box, similar to what we described earlier. You have like spread angle, distribution. You can just basically leave these at default for here. Next up is our curvature. Here we'll just enable this guy, and we have our details control. This is basically like an intensity value. You also have the ability to enable seams on the curvature map. So if you need to remove this, you can just uncheck this, and this controls the intensity of the seams on the map. Now, one important setting here is this algorithm where we have per pixel. And so what per pixel means is that it's utilizing the normal map to create this curvature. If I switch this to vertex, what it's going to do, it's going to use the low poly resolution mesh to create this curvature. And this is a good setting is, so let's say that you do not have a high resolution mesh, you can't bake the normal map, you don't have a normal map, but you still want to create a curvature from your low res mesh. You can just switch this algorithm here to per vertex. And here in your common settings for the high definition mesh, just add in the low res mesh again, and this will work. It'll create a curvature map for you. In our case, we're going to switch this to per pixel. Now I mentioned this was going to utilize the normal map. Our curvature, ambient occlusion, and world space bakers are going to be created based on the normal map that is baked from the normal baker. So let's say that you already have a normal map that you've imported and you're utilizing in this additional map slot, and you don't need to bake a high resolution mesh. If you just turn off this normal baker, these bakers here will utilize the map that is placed inside of this additional map slot to create these maps for you. For the ambient occlusion baker, you need to actually remove the high res mesh so that the ambient occlusion will be generated from the normal map in the additional map slot. In our case, we'll just enable our normal baker here again. We have our position, so we'll enable this baker. This has a mode, one axis or all. So by default, this is set to one axis, and the axis is set to Y. So here you can see that we could choose the X or Z as well. Now, the reason this is set to Y is because the generator that actually utilizes this position to create a particular wearing effect, it does this on the Y axis. And you have your normalization. You're going to need to set this to be sphere to get the best result. And then finally, we have this thickness. Now, thickness is going to create for us a map that basically describes the thickness of the mesh. And what this is used for is like subsurface scattering and such. The controls themselves are the same as the ambient occlusion. We're not really going to be utilizing this, so I'm just going to leave this baker off. Now finally, let's go back over here to our ID. Now our ID, let's just enable this baker here. We have some options for our color source. We have material color, vertex color, mesh ID, and so on. This baker is going to produce a map that's used for masking. And when this is set to material color, what it's going to do is it's going to use the materials assigned to the high definition mesh to generate this ID map. So for all of the materials in the high resolution mesh, it's going to take their color value and use those to produce the map. Now notice here in our low resolution, we only have 2 materials, but in the high resolution, I could have many materials. So I can create several different IDs. Another option that's very handy here is this vertex color. So let's just say you use something like ZBrush and you have poly paint, and you want to be able to take that polypane information and create an ID map out of that, you can just utilize this Vertex Color option. And then also here the mesh ID, it's going to take each different mesh part and use that to generate the ID. Now in that case we have the color generator. Do you want to use just random colors? Do you want to do a hue shift? So in the case of the mesh ID, you'd want to utilize this random color option here. What you'll typically use this with is pretty much going to be this material color. And so for this, it doesn't really matter what generator we have set for this. Material color is going to utilize the color value from the high resolution mesh. So let me jump over to Maya and show you what that looks like. So here I have my high resolution mesh. Notice here, I'm going to select this part. Notice this part has two different materials associated with it. This first material that I'm calling painted, I gave this a value of red. And in this second material, I just call this metal, I give this a value of gray. Now these material colors are going to be used for the IDs in the map. And it can be really useful because in your 3D program, you can kind of design or rough out how you want the materials to be placed on your mesh just by assigning just kind of various materials into different polygon parts or faces just to get an idea of how the material is going to look on your actual asset. So here we just save this high resolution mesh, and again, it's going to be used in that ID baking process. So here back in Painter, I have all of the baker set up, and I'll go ahead and click Bake Textures. So now our bake's finished. If we take a look at the additional maps, you can see that all of the bake maps have been placed into the correct slots. If we come over here to our shelf and go to our textures tab, are available here as well. So for instance, if we take a look, we have our ambient occlusion. Here is our color map. So again, notice that we have that red and that gray. So I can use these colors to create a mask selection from this. And you would do that using the mask to color selection tool in Painter. Here is my curvature map. Now again, the curvature map is just basically showing kind of like the edges of the mesh itself used in various weathering effects. Here we have our normal map. Here's our position map. Recall that the axis that we used was the y-axis, so the top of the mesh is going to be white, and as it moves down the y-axis to the bottom, it's going to become dark. And then here we have our world space normal map. So that's going to close out this video. We discussed how baking works inside of Substance Painter. We discussed the various options for each baker, and we also discussed how the ray casting is working and how you determine that max frontal and rear distance here inside of Painter.